All right, how's everyone feeling today?
Totally awesome, sir.
So we're moving on. Our next lesson, lesson 5. The question is, how is the rate at which work gets done calculated? And the rate at which work gets done has a special name. It's called power. Because if you can do work faster, you have more power. You're more powerful. If you have to do a job like, let's say, mow your lawn, and you want to get it done faster, well, you would need a more powerful lawnmower. So the rate at which work gets done is called power. We've had other rates before, and we want to get to the point where if we see something as a rate, we automatically know how to write down its formula. So this is kind of like a little clue to what the relationship is going to be. Think back when we studied average velocity. Average velocity was the rate at which displacement changes. Or when we calculated acceleration. Acceleration was the rate at which velocity changed. Think back to the corresponding formulas for those rates, and if you apply the same technique, you should be able to write the formula for power. Since power is how fast work gets done, does anyone want to speculate on the formula for power?
W over T?
Yes. Work divided by time, and if we wanted to write this in symbols, power P equals W over T. So for example, if we do 1 joule of work in 1 second, one divided by 1 is simply 1. Whatever math you do to the units, you do to, or whatever math you do to the numbers, you do to the units. If you did 1 joule of work in 1 second, the amount of power that you would need would be 1 joule per second. However, to honor another scientist, a joule per second is also referred to as a watt. And instead of writing out the whole word watt, we could just write out 1 W. 1 watt is 1 joule per second. You have to be a little bit careful because if the W follows the number, like right here, it stands for watt. But if the W is in the formula, what does it stand for there?
Work.
Work. You just gotta read it in context. You're probably familiar with watts when it comes to light bulbs. If you have a 60-watt light bulb, you now know what that means. 60 watts, 60 joules per second. So 60 joules of work is done every second to keep that light bulb on. If it's a 100-watt light bulb, 100 joules of work are done each second to keep that light bulb lit. So the formula for power is work divided by time. 9 times out of 10, that'll be the formula that you use. However, there there is a more obscure formula that sometimes you have to use to solve different problems. And let me derive that other formula as well. Power equals work divided by time. But recall, work is force times displacement. So we can rewrite that power equals force times displacement over time. Of course, we're not adding in the cosine theta term. So we're assuming that the force is acting in the direction of the forward motion. And we could rewrite this formula algebraically just by pulling the f forward out of the fraction. So it's f times x over t. And can anyone read your physics teacher's mind and state why it was rewritten that way and where we're going probably in the next step? Alyssa?
At velocity?
Yes. So another way of calculating the power is by taking the force being applied and multiplying it by the velocity of the object at that instant. More obscure formula, but sometimes, useful. And just to check out the units, we know that force is measured in newtons. Velocity is measured in meters per second. And another way of writing newtons times meters per second is we can simply say Newton times meter over second. And of course, a Newton times a meter, what is that? Joule. So that's joule per second, and a joule per second is a watt. So when you use that formula, you still get watts. So that's what you need to know to do lesson 5 homework.